I'd now like to work through one question that you did a similar question in the homework that I think is quite interesting. This question I put up here on the screen now so that you can see what question we're going to try to work through. A 4-meter tall cylinder. The cylinder is closed at the upper end and open on the bottom. Is filled with air at 20 degrees C. This cylinder is lowered into the ocean until the lower end is 100 meters deep. The temperature at that depth is 10 degrees C. The first question, assuming thermal equilibrium, how high does the water in this rise into the cylinder? And after we've done that, we'll try to see if we run a hose from the surface of the cylinder, how much air pressure is needed to expel this water. Okay, so basically, as I look at this question, my first step is probably I'm going to want to do diagrams. This looks like A, B, C. So we've got three situations we want to work. We've got a before situation, a middle situation for A, and a final situation for C. So I'd probably start by drawing my, try to draw my picture here. Okay, so basically I've got a 4 meters tall cylinder, okay? And not a very cool cylinder, but anyways, okay, there he is. He's my 4 meter tall cylinder, and basically at the beginning I'm basically on top of the water. Okay, let's make the water blue, okay? So I have my 4 millimeter cylinder, he's sitting on top of the thing. Okay, that's my initial condition. This is going to be like my position at start, before. And what information do I know about before? I know, what have I got here? I've got basically the temperature equals 293 K. The pressure equals 100 kilopascals, right? Atmosphere, it should be atmosphere right at the surface of the water. And what other? Volume equals 4 times the area of the cylinder. I don't know what that is. Okay, that's my before situation. Okay, let's move to our next situation for question A. I'll draw my picture there. That's the next step I want to do, is an A picture. What does my situation look like now? Okay, so basically I've got this guy still. Let's put him, okay, we're going to put another, I'm going to copy him across, okay, just so I can do the copying. I'll put this extra thing here, and then I'll put D. Let's move across our next situation in situation A. Okay, get rid of this guy. Get rid of the square because it's full there. Okay, so my new situation is going to be full of air, right? But it's not, and we're going to be going into my water way down here. Okay, and maybe I should make this arrange order. Okay, order to back. Okay, to back. Okay, so this guy, let's make him a little bit wider so I can see him clearly. This line, let's do its properties. Let's make him a thicker line. There. Okay, there he is. Okay, good. All right. So there's my next situation. Okay, in this case, let's try to see what do I know on my new situation. T equals 283. The volume is now equal to full. Okay, we need to define some units here. Okay, the water. How high does the water rise in the cylinder? So basically, what we want to find is this H. Is the question. So let's H equals question mark, which we don't know. This is what we want to try to find. And H is this little height right here. H, how much is the water rising in the cylinder? Okay, so the volume of gas now in the cylinder now is going to be 4 minus H. times A. The pressure, okay, I don't know the pressure now, so, but I should be able to figure it out, right? The pressure is going to be related to, okay, the other thing, 100, lower end is 100 meters deep. Okay, so we got one more thing, one more piece of information. This D equals 100 meters. Okay, so that's another important piece of information. I'm trying to get all my information on here that I need. Okay, so I've got D equals 100 meters. Let's do my, where does it go, that guy? No, not there. Okay, so anyway, so this distance is from here to here anyway. So let's, maybe I'll just put a line here saying from here to here. That's basically D, and if I want to do the property, okay, sorry, he's not that nice, but let's do the properties. He's a line. I don't see where I can put my ends on him. Okay, never mind. Okay, so there's my line. He's 100 meters deep anyways. This is the depth. Okay, so let's just, so we've got this depth down here for 100 meters, down to the bottom, right down to here is 100 meters. So the pressure, what's the pressure going to be? We know pressure is force per unit area, right? So first of all, there's going to be air pressure. So that's going to be, there's going to be 100 kPa plus this force coming down, the weight of the water, right? So the force of the water is going to be the mass of the water times gravity, right? And since it's a pressure, it's going to be divided by the area that we're occupying on. So the mass of water, we don't know that. We know that the mass of water is going to be related to rho, right? Rho for water. We can probably put that down here. The density of water at rho equals 1,000 kilograms per meters squared, right? Meters cubed is rho, right? Meters cubed, sorry, cubed. Okay, good. Rho is kilograms per meters cubed. I'm just going to then get the total pressure here is then going to be equal to, okay, we're going to have to rho times the depth of the water above it, which is going to be L, but there's a little bit coming up, so it's going to be L minus H. So this big distance D minus this little H that we don't know, or 100 minus H. Let's put rho in here, so it's 1,000. We're going to have the, it's a force, so there's a weight, so we have to have the 9.8 from gravity, right? 9.8 times gravity. Okay, so now I've got the final pressure as well, expressed in terms of H. Okay, so I've got my before, I've got my after. Let's try to get this thing closed down so you can see everything. Okay, great. So now I have now set up my problem. If I'm thinking about, I've got everything here I need for my before and after guy, and I'm going to think, okay, now I specified what I can. Now I can think about, I know I have to solve for H. What laws can I start to use? So part B, now I'm going to start to try to solve. Okay, first of all, I know that for ideal gas, I'm going to assume ideal gas equals nRT, right? PV equals nRT, or PV divided by T equals nR, the ideal gas law, right? And we know that N is not changing. The number of gas molecules here and here are going to be exactly the same. So that means that the before, P before, V before divided by T before is going to be equal to nR, which is going to be equal to P A V A, okay, V P after, V after, divided by T after. Okay, we have this equation now, right? We can then, well, we have everything for the before, right? We can now sort of substitute everything in. Would be my next line would be then substitute everything in. So I've got 100, 1, 2, 3. P times V is 4 times A divided by the temperature, 293. That's my left side. My right side, my after situation, is going to be all this 100 kilopascals times 1,000 times 100 minus H times 9.H. Let's for simplicity, let's make 9.8 equal to 10. Okay, so 10 meters per second squared gravity. So I can start to multiply this. So I've got 100,000 times, this is another 100, this is another 100 times 1,000, 100,000. So it's got 1, 1, 0. 1, 2, 3. Okay, this guy's got the, okay. Plus, I'm multiplying this guy out though, that's what I'm trying to do right now. Oh, minus, so minus, sorry, minus 1,000 H times 10, which means 10,000 H, right? Okay, there's my pressure. I now have my volume, which is 4 minus H times A. And we're going to have to divide it again by the temperature, 283. Next line. Next line, my next line, if I was writing this and trying to work through this, the way I'm working through, so you're seeing how I'm thinking through these things by left side, right side. Okay, A's cancel, right? A's cancel. And I'm going to get a quadratic equation with H squared in it. Okay, so now I'm going to have to solve this equation for H squared. Okay, you have the 4 minus H, the 10,000 minus H. So we're going to have to do a fair bit of multiplication out here. And then we will need to solve the quadratic equation for H. And since it's a quadratic equation, we'll get two values. One of the volumes will make sense. One of them will not make sense. I will let you do the math. Okay, but the final answer is going to give us approximately H should be approximately 3 meters. Okay, I'm doing this not as high accuracy as you would. For example, rho, you would want to use the actual rho for seawater, which is I think about 1030. You'd probably want to actually use the actual acceleration, a closer value for gravity, maybe 9.8. You probably also want to use a more accurate value for atmospheric pressure, which would be 101, right? Kilopascals if we're using a more accurate value for the pressure, and then work through the same question. Now, the second question now we're asked for is, how much air pressure is needed to expel this water? Okay, that's just going to be this guy again, right? This pressure, right? We're just going to have to displace all the water, so we need to have the same amount of pressure at this point as water pushing up. So if I'm going to add more air into here, I've got to push in enough air so that the pressure of the air exactly matches the pressure putting up at the bottom. So in other words, I've got to make sure the pressure from the water pushing up is equal to the pressure from the air coming down. That's basically what is happening here, right? The pressure of the air coming down is equal to the pressure of the water coming up. So if I want to solve that for that, I'm just going to use this same equation again. Let's quickly go for part B. So the pressure, okay, and I'm just not going to need so this is the pressure at the surface right here. I want the pressure at the bottom when I add more air in. That's just going to have to switch that to 100. Okay, and that should give me a pressure of somewhere around, and you can do the math again. I'll have to make this 101. Okay, and you can quickly do the math and find out that the final amount of mass should be approximately 11 times 101 kilopascals. So or I would write it just a simple 11 ATM or 11 bar. Okay, or ATM, whichever unit you want to use. So this is, I think, an interesting question because it's very important at the very beginning you set up and try to understand what the problem is and what information we have before we start the problem. Then we can then use the laws and quickly solve the problem with ideal gas law. So I hope this was enjoyable and hopefully you learned something from this short video.